Dear participants, in today's session we shall discuss about the applications of artificial intelligence in Internet of Things. As we know, Internet is transforming from the Internet of computers to the Internet of Things over the years. Massively interconnected systems, which are also known as cyber physical systems, are emerging from the assimilation of many facets like infrastructure, embedded devices, smart objects, humans and physical environment. This all is heading to a huge Internet of everything in a smart cyber physical earth. Internet of Things and cyber physical systems, when they are conjugated with data science, it may emerge as the next smart revolution. Thus, IoT with AI can become a huge breakthrough, easing human life. However, there are certain concerns also in this, which include security concerns and ethical issues. Another issue which is impeding the growth of this field is a huge data is generated and weak computation power is available as of now. So, all these are areas of study to make this more properly applicable in the real world. As we know, Internet of Things is something which anticipates a world saturated with intelligent gadgets, which are frequently called smart objects. And these smart objects are interconnected through internet or any other communication medium. With the advent of Internet of everything in a smart cyber physical earth, we have seen that certain concerns like huge data which has been generated with much weaker computation power is something which is impeding its growth. The answer to this is research in AI and data science, because through data science we can find the answers to how to manage this huge amount of data. Thus, IoT and AI can become a huge breakthrough once they are combined together. When we talk of smartness, big data analysis with machine learning is the way to go. Human intelligence basically is taking a perfect decision at an appropriate time. When we talk of artificial intelligence, it is a takeaway from human intelligence. So, artificial intelligence would be choosing a right decision at the appropriate time. When we discuss AI, it is not a standalone discipline, it is has a interdisciplinary nature. Fields as diverse as philosophy, computer science, mathematics, statistics, biology, physics, sociology, psychology, etc., are combined together in AI. So, AI, if you are defining it in a formal way, is the science of instilling intelligence in machines, so that they are capable of doing tasks that are traditionally required the human mind. So, whatever we are doing through our mind, we are trying to simulate or we are trying to emulate it through AI. Data is something which is generated while doing all this, and in real world data has some very unwelcome properties. That includes huge volume of data, and that huge volume is also unstructured in nature. The data sources are varied and it needs real time processing. Also, it changes continuously. So, what is the way forward? Machine learning is the way forward, and machine learning basically gives inanimate systems the ability to learn without actually having to program them explicitly. It is about learning from experience rather than actually programming for its functioning. So, adaptive learning is what machine learning is all about. So many adaptive learning algorithms have used what is happening in various devices or various things in the real world or various species in the real world. For example, earthworm is a inspiration for the development of smart thermostats, and adaptive learning of new responses is the quality which is actually picked up from the earthworm to develop a smart thermostat. Similarly, learning by trial and error, which is picked up from fish, that was used to develop a Kronos robo. Then learning by setting a goal, acting to achieve it and then assessing itself. This quality or this property of the octopus was used to develop the application in cog. Self consciousness and higher order thinking, which is something which chimpanzees exhibit, that is used in development of Siri, which we all use in our smartphones. Emotions like frustration and happiness, which a small child from 1 to 6-year-old, those emotions are used to develop Cosmo. So, that is the object which is developed basically simulating the emotions of a 1 to 6-year-old child. Now, full theory of mind interpret human emotions and responding back accordingly, which is something a 7 to 11-year-old child does. It is programmed into a device called or a robo called Pepper. Then Turing test simulation and experiments used a 12-plus-year-old human mind, and this particular thing, this test was devised by MIT's AI program by Eugene Gostman. Now, when we talk of Internet of Things, so many fields are merging into it. For example, high performance computing, cognitive science, real time analytics, big data analytics, machine learning, wireless sensor networks, then network control, software, actuators, sensors, embedded systems, they are all part of, or they all merge into the field of IoT. So, when we talk of all these things like IoT, intelligence and like that, there are certain relations which we can define to actually understand how they are interlinked, how they merge into each other. Things, when they are intersected with intelligence, we get what is called smart objects or smart devices. Similarly, a network intersected with intelligence will give you a smart network. Then things intersected with network would give us network devices. Similarly, services and intelligence, once they are intersected, we get smart services. Services and network intersected gives us internet services. Then things and intelligence and network, the intersection of all these things will give us Internet of Things. Internet services and intelligence, once they are intersected, their common cusp gives us Internet of Services. And then Internet of Things, its union with the Internet of Services will give us Internet of Everything, which would be having physical as well as smart devices. So, things and everything, when we talk of these two terms, when we are talking about IoT and IoE, we must be very clear about the concept of things and the concept of everything. One straightforward concept that may come to the mind is anything that can be connected may be the thing in IoT. However, we can define it in the other way around also. There can be more features in making a physical object a thing. The thing, which could be a living thing or a non-living thing, should have a way to generate or collect data. That is the first property a thing should have. A way to process data, a way to spend or receive data, a way to identify itself. So, thing is a physical object, whereas IO is the things and intelligent services. Services, as we know, are not physical, they are basically abstract. When we talk of AI enabled IoT, there are some examples of the existing IoT services with the working of AI behind them, and these examples we use in our everyday life also. For example, we use voice assistants like Alexa, Siri and so on in our smartphones. Then certain robots like Pepper, Sophia, they are also in application in use in different applications. Then robotic kitchens are there, which are actually being used. Smart devices like smart ovens, sky bells, smart lights, automotive AI and certain industrial IoT applications like Primer and Pluto Shift, they are all part of our AI enabled IoT applications which are presently deployed in the real world. So, once we are talking about AI enabled IoT, we should understand that what cyber physical systems are in a formal way. This term cyber physical systems, it emerged around 2006 and it was coined by Helen Gill at the National Science Foundation in the United States. As far as NSF or the National Science Foundation definition is concerned, they say it is an engineered system that are built from and depend upon the seamless integration of computational algorithms and physical components. For example, let us consider an example of what we can visualize in terms of cyber physical systems. You are going in a car somewhere, the car meets with an accident. Normally what is happening is once it meets with an accident, somebody calls an ambulance, somebody would call police, you will reach an hospital. In that hospital, the doctors would ask that, okay, this is a police case, so let the police register a case first. This is something which would waste very precious time in an accident case. What would happen if you visualize a system in which once that accident happens, the system is immediately informing the nearest hospital, and the system is informing the nearest police station, and the police reaches before or parallel to when you reach the hospital in an ambulance. So, that way a lot of time is saved. So, that is what we are visualizing in a CPS kind of a system. CPS again, like IoT, is a combination of so many disciplines. There is machine learning, which is big use in this. For example, machine learning is basically, it is a platform to learn the trends of the system from data generated in the past to make an informed decision in future without manual monitoring. And then big data analytics, or what we call data science, that is another area which machine learning uses. So, all the data that is generated in a huge interconnected system will constitute a massive content that will be processed and analyzed over time to make the system better. So, usually machine learning algorithms are modified and adapted to handle this big data scenario. Then design is another area which is part of machine learning. The overall system needs a robust, tolerant and efficient design which connects all the components as required. Process science, its usage would be different industrial manufacturing processes are demanding the use of automation in their production lines. Then wireless sensor networks for communication are required. The whole system would depend on communication. Wireless connections between each component of the system would help pass information from one object to the another. So, within a system or within objects that would be required. Software is the heart of all this functioning. All the working devices in system need a software to work. These softwares would be system and task specific. Then embedded systems, the gadgets, the devices that constitute a CPS would contain embedded systems like camera, temperature measurement sensors. Each device would have different embedded systems or sensors as per their requirements. Cybernetics is another field of study which is relevant to mechanical, physical, biological, cognitive and social systems. Mechatronics and robotics, these are fields which seek human like actions for different tasks. So, these will not be manually handled for given some fixed instructions, rather they will be intelligent enough to know what needs to be done at the right time. Then high performance or cloud computing is something which is part of the machine learning systems. Typically, the issues considered cannot be solved on a single commodity computer because of the huge amount of data. So, within a sensible amount of time you can't handle all that. So, excessively complex operations are required, or the execution is incomprehensible because of the restricted accessible assets. A lot of training data is required. So, these systems are required here. Then cognitive science. What is cognitive science? It is predominantly involving concepts from psychology, philosophy, neuroscience, then anthropology, computer science and linguistics. So, it is a study of mind and the level of intelligence. The goal is to understand the nature of knowledge in various living beings and how that knowledge is acquired, processed and used. So, that we can then mimic in our systems. So, what are the various components in a IoT CPS system? When we talk of its components, the IoT architecture tree would have Internet of Things. Under that you will have things. Things can be a smart object or a identity network. Then data storage and data processing, which we call data science. Then security is another component. So, what are smart objects actually? We have been talking about this term. Two elements to consider in the physical world are a physical entity and a smart object. A physical entity or a physical thing can be represented in the cyber world by a D by its digital proxy, which is called a DP. So, digital properties have two fundamental properties. One is each digital proxy must have a single ID that distinguishes it from others. The association between the digital proxy and the physical entity must be established automatically through this DP. Then relevant digital parameters pertaining to the characteristics of the physical entity can be refreshed upon any difference in the former. Similarly, changes that influence the digital proxy might be shown on the physical entity in the physical world through actuators. So, that is how we can show it in the physical world, we can use actuators for that. Then data storage and data processing. That is the main motive of IoT and CPS is to create an autonomous system that can handle different situations across the globe, and those situations would help eventually assist humans to lead a better life. So, the basic IoT CPS framework consists of smart objects and the connections between them. Then communication networks are very important here. Continuous analysis of big data over these platforms demand an efficient and reliable network structure. Virtualization of nearly every physical thing imposes a big challenge on the network service providers. So, there should be advanced wireless technologies that can handle such enormous eruption of devices. Smart devices need a smart network infrastructure. Artificial intelligence and IoT CPS, how they are actually working in this system is that we know that the first industrial revolution happened during 1760 to 1840, and during that revolution, industrial revolution, a rapid growth of machines took place. In the second industrial revolution 1870 to 1914, people became richer in urban. Currently what is happening is a smart or a cyber revolution is underway. A number of interdisciplinary technologies and sciences are converging and giving rise to smarter softwares, newer materials, very flexible and robust, then groundbreaking inventions like 3D printers and a whole range of personalized web services. So, AI enabled IoT CPS would basically be a good machine learning system in order to deal such big data, and what such a system would require is data preparation capabilities, learning algorithms, basic and advanced both, automation and adaptive processes, scalability, then ensemble modeling and real time decision making. In a cognitive AI and IoT CPS system, cognition, as we earlier also discussed, is a process of acquiring knowledge and understanding through thoughts, then experience and senses. So, intuitively cognitive IoT can be thought of as an extension of IoT, which is capable of understanding, reasoning and learning. When we talk of AI enabled IoT CPS, energy utilization, routing or traffic handling, cost savings, these are some of the applications. Challenges in this system would be, as we see in the recent IoT trends, that data is coming at a faster speed from various sources in various forms. So, basically it obviously exceeds the abilities of an information system to imbibe, store and analyze and process it. The field of AI needs more development with the advent of such IoT CPS infrastructure. Security is another major concern, as in this age of technology there will be cyber wars. We already see that cyber security is a big challenge and it is even impeding national security sometimes. So, challenges of this CPS include a number of specific challenges which get raised due to the large scale nature of this CPS system. Any physical system may be predicted partially by simulation, but for a cyber process it is difficult to predict the behavior. This difficulty to predict the behavior is one big challenge. When the two worlds come together in a CPS, they need to operate in synchronity. They have to be synchronized. It poses a big challenge for the global system control. There are even bigger challenges with the big data. So, when we talk of challenges of IoT, the basic challenges are connectivity, security and trust, interoperability, scale of the whole system, then energy and environment. So, these challenges are impeding the growth of IoT systems. When we talk of data analysis, which is so important in these systems, the challenges which are impeding data analysis is analyzing the massive and fast flowing data, which requires advanced technologies like virtualization softwares, then adaptable cloud computing, etc. It also needs very powerful high performance computing devices that can provide the mechanism to discover the underlying insights in big data. So, to conclude our talk, we can hope that in future people will be wearing intelligent gadgets, eating intelligent capsules that judge the impact of the medicine on the body, living inside intelligent homes and so on. With the right policies, we can get the best of both worlds, that is automation without rampant unemployment. With this we come to the end of the session. Thank you all for a very patient hearing.